In this paper, we propose the first approach to generating landscape cinemagraph, utilizing the deep features of a pre-trained StyleGAN. Specifically, we propose multi-scale deep feature warping to apply motion to the deep feature space of StyleGAN. Using this method, we can achieve the following. First, we can generate high-quality cinemagraphs without training a large image generator from scratch or fine-tuning. Second, we systematically improve the resolution of the output video to 1024 by 1024, and third, we can edit the appearance and style of the cinemagraphs using the properties of StyleGAN for image stylization and editing. Now let's take a look at the cinemagraph results generated by our method. From the given landscape images, our method generates high-quality landscape cinemagraphs with plausible looping animation. The results are generated at 1024 by 1024 resolution, preserving the beautiful details of the original image. Here, we share more visual result generated using our approach. The appearance changes of the scene can be achieved using a style mixing technique. Here, we present the same scene modified in 4 different styles. We now compare the results of our method with those of previous approaches. First, we compare our method with animating landscape, which is one of the baselines in cinemagraph generation. Because of the recurrent backward warping operation, the results show stretching artifacts in the indicated region. In contrast, by applying forward warping to the deep features of a pre-trained StyleGAN, our method generates plausible motion. We further compare our method with deep landscape, another baseline in cinemagraph generation. By forward warping the deep features of StyleGAN, our method generates cinemagraph with less noticeable artifacts. The indicated regions show the advantages of our GAN inversion method in keeping the texture details of the original input image. In addition, their method often fails to differentiate the static and dynamic regions, which result in motions in static regions. In contrast, our method utilizes a segmentation mask predicted using the deep features of StyleGAN to refine the motion prediction results, which leads to achieving static consistency. We compare our method with the Eulerian motion field. By training an encoder-decoder network from scratch on a low-quality video dataset, their method fails to reconstruct the detailed textures accurately. In contrast, our method leverages a StyleGAN model pre-trained on high-quality images, resulting in cinemagraphs with high perceptual qualities. Also, their method sometimes produces erroneous movements in static regions. By using segmentation masks obtained from the deep features of StyleGAN, our method achieves accurate segmentation between static and dynamic regions. We compare our method with text-to-cinemagraph. Their method introduces some artifacts near the static region boundary. In contrast, utilizing the deep features of a pre-trained StyleGAN for mask prediction and refining the static region boundary, our method well preserves structural details of the source image. Next, we compare our method with MocoGAN HD, an unconditional video generation approach using a pre-trained StyleGAN. Achieving static consistency is important for cinemagraphs, as their core property is to preserve the original content in static regions. Because their method explores the latent space that lacks spatial information, the generated frames deviate significantly from the original image, which is not desired in cinemagraphs. Our method utilizes the deep features of a pre-trained StyleGAN, exhibiting static consistencies with the clouds moving while the ground remains static. Here, we provide some visual results for our ablation studies. Without our deep feature warping technique, the warped RGB images contain tearing artifacts in the animated regions. The alternative for warping the deep features of a pre-trained StyleGAN is to use backward warping. We observed that this approach produces stretching artifacts. Without our multi-scale deep feature warping approach, warping a single feature results in blurry textures in the animated regions. Without a segmentation mask from our mask predictor, we observe erroneous movements in static regions.